Hello everyone, this is Mix K. Today I'm going to be going through a short video where I am going to discuss the first page of notes in your packet. So we are starting our topic on intermolecular forces, which we will talk about more in class. But what I want you guys to look at today is a little bit about polarity. So I want to remind you, we have two different types of covalent molecules. We have polar and nonpolar. Now polar means that this molecule has a charge. So polar means charged, okay? Which means nonpolar means no charge. Now, why do we have this difference? It has to do with electronegativity. So electronegativity was our measurement of how well an atom attracts electrons. Okay, so in this little comic, our polar bears have really high electronegativities. They're very good at attracting electrons. And our penguins have very low electronegativities. They're not as good at attracting electrons, and so they get the electrons pulled away from them. Okay. Now, in a polar covalent compound, we have shares electrons unequally. One of them is better at attracting electrons than the other. One of them has a higher electronegativity than the other. Okay? So the difference in electronegativity is bigger. Okay? It's a bigger difference. One's stronger at attracting electrons than the other. And in a polar covalent compound, the electrons are being pulled in the same direction. So let's take a look at this here. In this diagram, we have an atom with a high electronegativity, our polar bear, an atom with a low electronegativity, our penguin, and they are fighting over an ice cream cone. Now, each of these scoops is representing an electron, and them holding on to the electron represents the bond. Okay? So both of them holding on to this electron. But who's pulling the electrons closer? Our polar bear is pulling the ice cream closer to him. So our more electronegative atom attracts the electrons more. Now if we look, that means this penguin isn't holding on very hard to this ice cream cone. This electronegative atom is not holding on very hard to the electrons. What does this do? Well, the more electronegative atom pulls the electrons closer, which means this side is going to be a little bit negative. The electrons get pulled away from the hydrogen here, so this side is a little bit positive. Okay, so we have a positive and negative charge now. Polar means charged. We have another word for this. Dipole means a separation of charges. Positive on one side, negative on the other. Now here, even though this polar bear is fighting two penguins, he is pulling in the same direction. So when we look here, water is polar because the oxygen pulls the electrons up and away from hydrogen. It's pulling them in the same direction. This is like a really strong guy doing tug of war against two different teams. But because he's pulling them both in the same direction, he's going to win that tug of war. So what does that mean? That means our oxygen's a little bit negative and our hydrogens are a little bit positive. Oxygen's a little negative, hydrogen's a little positive. Now what happens when a negative and positive come near each other? They attract. And that's what holds our molecules together. The positive and negative attract in the two polar molecules, and it keeps them stuck together. Now in a nonpolar one, they share equally. So both are pulling just as strong on those electrons. Those pulls cancel out, and the electrons are shared equally, which means no charge. No charge. So both these polar bears are sharing the electrons equally. Here, they're both pulling away from carbon, but they're pulling in equal and opposite directions, so they share equally. Sharing equally means no charge. Now, what does this tell us about how things mix and dissolve? So a couple vocab words. A solute is what you are dissolving. So if I was making salt water, the salt would be my solute. My solvent is what does the dissolving, so it would be my water. Soluble means it can dissolve, and insoluble means it cannot. So why do things mix together? We have a phrase called like dissolves like. Things with similar charges will dissolve each other. So for example, these two compounds could dissolve in each other because they both have charges. If they're both polar, they can mix because the negative from one will attract the positive of the other. Now, if you have something that's nonpolar, they can also mix. Okay? They don't have any charges getting in the way of them mixing together. We'll talk more in detail about how a nonpolar substances mix, but the important thing to remember is charges mix with charges, no charges mix with things that have no charges. So no charge mixes together, charges mix together. Okay? We end up with this phrase, like dissolves like. So polar dissolves polar, charge dissolves charge, nonpolar dissolves nonpolar. Okay? Getting the idea. Okay, that's where I'm going to leave it for today. Have a wonderful day, everybody.